Hello everyone, this is Sheila Ratna Bansode from Walchand Institute of Technology, Solapur. Today we are going to see the topic priming of centrifugal pumps and multistage in centrifugal pumps. Before we move on, let's see what are the learning outcomes. At the end of this session, students will be able to discuss priming and its types. Students will also be able to discuss multistage pumps and its types. Now, before we move on, I suggest you to pause the video at this moment and recall the construction and working of centrifugal pump. Moving further, priming. Let us focus on what is meant by priming. The need for priming we'll discuss first. Here you can see on the screen the head developed by the impeller, that is the pressure developed by the impeller, is equal to VW2, that is whirl velocity at output, into U2, that is tangential velocity at output, divided by acceleration due to gravity. This is the total head developed by the impeller. Now, as we see, this head developed is independent of density. There is no density term in this. Now, initially, before we start the pump, the suction pipe, the casing and the delivery pipe are occupied by air. So, the head developed in the form of air column. So, whatever position, whatever space is there in the pump, right from suction pipe to the delivery pipe, is occupied by the pump, and the head developed, the pressure developed will be in terms or in related to air, in the form of air. So the pressure developed, as we know, pressure is rho gh. As far as air is concerned, for air we have density of air into acceleration due to gravity and height h. Now we know that we will be working with the fluid rather than air. So to calculate the pressure developed for the liquid, we can equate the pressure developed for air is equal to pressure developed for the liquid. Now, as specifically we know, centrifugal pumps are used to lift fluids. Let us consider in this case water. Now here, as you can see, as the head will be very low because of large value of density. So larger the value of density, the lower will be the head developed. And as far as we know, when the suction begins, the pressure is slightly developed, so priming is required. Hence, liquid may not be sucked. As head developed is less and density of liquid is more, the desired suction of the fluid will not take place. Thus, priming we can define as it is a process of filling suction pipe, casing, delivery pipe up to the delivery wall with the liquid of which pressure is to be increased. So this is the liquid to be lifted: suction pipe, casing and the delivery pipe up to delivery wall. This is the total area that we need to be filled with the fluid that we are thinking to, or we need to lift with the help of centrifugal pump. Now when you fill this completely, the desired head will be developed and this water or this fluid will be sucked to reach the desired location. Unless and until the desired pressure is achieved or the desired head is achieved, the suction will not happen. Now, to carry out this priming, there are different methods. Let us look into each. Now, the first method of priming is manual priming, which is suitable for very small pumps or pumps that are used for domestic applications. Now, here is the diagram. We have a centrifugal pump sketch over here. This is the casing, this is the suction valve. Here we see an additional unit that is called as air vent valve. Then we have the delivery pipe. At the delivery pipe, we have a funnel like arrangement. This funnel like arrangement is used to fill the desired fluid into the pump, into the delivery valve, delivery pipe and suction pipe. Now this funnel is used for priming. With a small container or a mug like container, we pour water into this funnel, allow the water to flow into the delivery pipe, the casing and the suction. Now at the same time, this air vent is allowed to open. When the water starts filling into this area, that is delivery pipe, casing and suction, air will start to escape through this air vent. Once the water starts coming from this air vent, we will close this air vent, stop filling water into the funnel, and then we start the pump. That is, we start the pump after priming. This is priming with the help of manual arrangement. Then we have from overhead tanks, that is suitable for large pumps. See, if the capacity of the pump is more, it is quite difficult or it will be quite time consuming to fill this entire area, that is delivery pipe, casing and suction pipe of large pumps with manual pouring of water. So instead of that, what we do, we connect a small pipe at the delivery pipe end to a overhead tank. This area or this opening of the pipe will be connected to the overhead tank. That overhead tank water or fluid will be allowed to flow into the centrifugal pump that is used to lift that particular fluid. Similarly, filling of delivery pipe, casing and suction pipe will be done with the help of this. Once the water starts coming out of your air vent, the supply of fluid from the overhead tank or water from the overhead tank is stopped, and then this required centrifugal pump is started. So this is priming with the help of overhead tank. Moving further, now with the help of vacuum pump. Here, as you can see, in the first case we had a funnel and we poured the desired fluid with the help of a small container or a mug. Then in the second case, what we saw is the opening connected to overhead tank for large pumps. Now here, as in case with the vacuum pumps, here a small reciprocating pump is provided. Now this reciprocating pump is either powered with a prime mover or it is operated manually. Now what does this pump do? This pump allows to suck air from the suction pipe, from the casing and from the delivery pipe, and it is allowed to move out in the atmosphere. So here you can see it is air out. So we take out all the air from this area, that is casing, suction pipe and delivery pipe, through this reciprocating pump or vacuum pump and allowed to flow into the atmosphere. Now this area is totally free of air. Then we start the pump. As the pressure over here is reduced, the water starts flowing into the casing and your pump will perform as per the desired. Now next what we have is self-priming pumps. As far as self-priming pumps are concerned, these pumps mix the air with the recirculating water in the casing. The air separates from the liquid and is discharged from the casing. When you start the pump, it will start moving. It will allow to discharge the pump, discharge the air and occupied by the fluid. When all the air in the suction line, has been displaced, the pump will deliver the liquid at the desired pressure. Even in some cases, there is a small container or chamber where water will be stored, and that water or that fluid will be used for priming when you start the pump. So this was with methods of priming. Next, moving on to multi-stage centrifugal pumps. Now, multi-stage pumps are needed when single pump cannot satisfy requirement of either discharge or pressure head. As we all know, we require pumps to get the desired pressure or to get the desired discharge. Example, I am allowing to transport a fluid from ground floor to certain n number of floors. There, the overhead tank is fitted. That overhead tank might be taking too long to fill. Hence, the discharge is low, and or the desired pressure, it might not be reaching to that desired floor. There, the pressure is low. So in this case, we go for multi-staging. Say a pump takes lot of time to fill a tank, discharge is not sufficient. Say a pump is not capable of lifting water to a certain floor, pressure head is not sufficient. Now, if a centrifugal pump consists of 2 or more impellers, the pump is called a multistage centrifugal pump. There we have two stages or two classifications, that is multistage for high discharge and multistage pump for high head. Let us discuss the first. Now, multistage for high discharge. As far as this is concerned, if a single pump is taking a lot of time to fill the tank, we can use more pumps to fill the same tank in less time. On screen you can see a diagram. Let us consider this first pump and this second pump. The discharge of both the pumps is connected to a common pipe. The discharge of first acts as the suction for second, and addition of both the discharge, that is Q1 plus Q2, will be at the end. So this is when we have less discharge. The pump is parallel, shaft of pumps are parallel. Now next, here output of first impeller is taken as input to second impeller. Here output of second impeller is taken as input to third impeller, and so on. So output from one pump is taken into another pump, and then you will get the desired pressure head. Here discharge is not increased, but the pressure is definitely increased. So this was his multi-stages of pump. So one shaft, number of impellers are arranged, impellers in series to each other. Then if n number of impellers are mounted on a single shaft and HM is the head developed, that is manometric head by each impeller, then total head is equal to n into HM. But discharge through each impeller is same. These are the references. Thank you.